Okay, just to remind you, for page 9 of Trig Equations and Identities workbook, what are the double angle identities, and they're right here. Okay, use an appropriate double angle formula to simplify each of these. Okay, so let's do A first. 2 sine cosine. Sometimes to abbreviate this, I'll just write cosine and sine. I won't write alpha or theta or whatever, as long as it's a single angle. This one looks pretty easy, right? Because it looks exactly like that one. So I could write that it's equal to sine of 2 alpha. Okay, that was A. D. D is 2 cosine squared. And just write cosine squared because it's a single angle. Minus 1. 2 cosine squared minus 1. 2 cosine squared minus 1. That kind of looks like that one, right? 2 cosine squared minus 1. So that's equal to cosine of 2 beta, because it was beta. Cosine of 2 beta. And I have to be careful not to make that into a small 2. It's a big 2. It's 2 beta. It's not cosine squared beta. Cosine 2 beta. Okay, that was D. G. 2 sine squared minus 1. 2 sine squared minus 1. That kind of looks like that, but not quite, right? Because it's the negative. It's the inverse. So 2 sine squared m minus 1 would be actually negative cosine of 2m. The J. 2 sine 2a times cosine of 2a. Okay, so this would be, it looks like this one, right? 2 sine cosine. So instead of 2 sine cosine, we would write cosine of 2 theta, but in this case, theta is equal to 2a. So we're going to write sine of 4a, because it's 2 times 2 theta. Sine of 4a. Okay, m. 1 minus 2 cosine squared 3 beta. So this basically looks like this one, but it's, first of all, it's the inverse. So instead of cosine 2 theta, it would be minus cosine of 2 theta. And the theta in this case is not theta, it's equal to 3 beta. So then it would be minus cosine of 6 beta. Okay. P. Cosine squared minus sine squared with 2a in for theta. Cosine squared minus sine squared. Now wait a second, that's one I didn't write down here, but here you go. There you go. Cosine of 2 theta is equal to cosine squared minus sine squared. So since I have cosine squared minus sine squared, that's equal to cosine of 2 theta. So cosine of 2 theta is basically the answer. But in this case, theta is not equal to theta, it's equal to 2a. So cosine of 2 theta is actually cosine of 4a. Okay? All right. Moving on. Sine theta plus cosine theta quantity squared is equal to 1 plus sine 2 theta. So you're going to use the double angle identities until you get that, the left side is equal to the right side. Okay. The obvious thing to do here is to do FOIL and expand this. So let's do that first. So you have sine squared. And remember, FOIL, you need the O and the I. You can't just write sine squared plus cosine squared. That's not the answer. It's sine squared plus 2 sine cosine plus cosine squared equals 1 plus sine of 2 theta. And remember, sine squared plus cosine squared is equal to 1 as long as the two angles are the same. So it's 1 and then plus 2 sine theta cosine theta. And what do you know? 1 plus sine 2 theta. This part and this part are the same according to the double angle formulas, right? Look right there. 2 sine theta, cosine theta is sine 2 theta. And so 1, of course, is the same. And then this is the same. So we have shown that they are the same. solve exactly for x where x is between 0 and 2 pi. Okay, so now maybe we're going to have to use a calculator or our knowledge of 30, 60 degree angle, 45 degree angles. Okay, so let's do A first. Sine of 2x plus sine of x equals 0. So let's first try to change this double angle into a single angle. So instead of sine of 2x, we're going to put 2 sine of x plus cosine of x plus sine of x equals 0. So now we have, it's not plus cosine of x, it's times cosine of x. And I'm not going to put a multiplication sign because that just makes it look like an x. So 2 sine cosine is, and then let's see, what can we do? We can factor out a sine x, see if that helps. Sine x, 2 cosine x plus 1 equals 0. So now, to figure out when this whole thing equals 0, we could say, okay, when does this equal 0? And then when does this equal 0? Do that separately, and then whenever either one equals 0, the whole thing is equal to 0. We've used that technique many times, right? So when does sine x equal to 0? Sine x is equal to 0 when x equals 0, or when x equals pi, or when x equals 2 pi. Okay, those are 3 points where sine of x equals 0, between 0 and 2 pi. And then what about this other part, 2 cosine of x plus 1? When does that equal to 0? 2 cosine x plus 1 equals 0. Well, we'll use some algebra and isolate cosine. We subtract 1 from both sides, we get negative 1 equals 2 cosine x. Cosine x equals negative 1/2. And take the, let's see, cosine of x equals negative 1/2. So now we look at our unit circle. When do we get a cosine of negative 1/2? Well, that's like below the x-axis. That would be triangles like this or like this, right? Not that. Sorry. It would be these two triangles, right? Negative 1 and 2, negative 1 and 2. So it would be 2/3 pi, and also it would be 2/3 more than that, so it would be 4/3 pi. So those would be the two solutions for that part of the equation. Okay, so like the solutions for this part are here, and the solutions for this part are here. And together, those are all the solutions. Okay, let's do one more. We're going to do C. Sine of 2x plus 3 sine of x equals 0. So again, we're going to expand this. So we're going to, instead of sine of 2x, we're going to have 2 sine of x cosine of x, which is the double angle identity. And we're going to add 3 sine of x equals 0. And then we're going to factor out a sine of x. So we're going to have sine of x, 2 cosine of x plus 3 equals 0. And then we're going to solve these separately. So when does that equal to 0, and when does that equal to 0? Now, they're not going to equal 0 at the same time, but that doesn't matter. So we already know that the solution for sine of x equal to 0 is going to be 0, pi, and 2 pi. Okay, and so now we just need to do this other one here, which is a little bit more complicated than last time. Subtract 3 from both sides, and then we end up with 2 cosine x equals negative 3. Then we're going to divide both sides by 2, and we get cosine of x equals negative 3/2. Okay, and this is not, something's wrong here. We can't have a cosine that's bigger than -1, or I mean less than -1. So cosine of x equals negative 3/2, that never happens, right? Cosine is always between negative 1 and 1. So basically what we're saying here is there's no solutions to this part here, okay? So that's the end of that. So basically the only solutions are here, okay? All right, use the double angle formula to show that sine squared equals 1/2 times 1/2 minus 1/2 cosine of 2 theta. Cosine of 2 theta, this kind of looks like, if we factor out 1/2, it kind of looks like a double angle formula. One half, 1 minus cosine of 2 theta. So cosine of 2 theta, remember, can be rewritten as, and it looks like we want a sine squared in the formula, so what if we wrote it as this one here, 1 minus 2 sine squared theta. So it would be 1/2 times 1 minus cosine 2 theta is, so 1 minus sine squared theta. 1 minus 2 sine squared theta. Okay. So that would be equal to 1/2 times 1 minus 1 plus 2 sine squared theta. The ones cancel out. The half and the 1/2 multiply together get a 1, and then you end up with sine squared theta. So you're done. Okay. Part E, trig equations in quadratic form. Solve for x between 0 to 2 pi, giving your answers as exact values. So let's see, 2 sine squared plus sine equals 0. Now this is going to be, you're going to use the Jinsel method, and you're going to substitute something like t equals sine of x. Okay, and then you're going to get a quadratic, 2t squared plus t equals 0. And then you're going to say, okay, so t times 2 plus t equals 0. So that means t equals 0, or 2 plus t equals 0. So t equals 0 means that sine of x equals 0. 2 plus t equals 0 means 2 plus sine of x equals 0, because we substitute back in the sine x after we factor it. We just put the t in there to make it easier to factor. Sine of x equals 0, we know the solutions for that. For the solutions between 0 and 2 pi would be, like we've seen before, are 0, pi, and 2 pi. Okay, and then for this one here, sine of x equals negative 2. X is, there is no solution, right? Because sine of x is never equal to negative 2. It's between negative 1 and 1. So this part of the equation, 2 plus t equals 0, yields no solution. So the only solutions are these. Okay. Let's do number C, letter C. 2 cosine squared x plus cosine of x minus 1. So let's substitute in here t squared. We'll substitute in here t. 2t squared plus t minus 1. So what does this give us? If we factor it, we get 2t, t, and then we have negative 1 and negative 1, except one of these is going to be a positive 1. Let's see, does that work? This would be no, that doesn't work. We just want at, we don't want. So this would be positive, this would be negative. Does that work now? Yes, it does. Okay, so, and then let's set this equal to 0, and let's set this equal to 0, so it's 2t minus 1 equals 0, which is, and then we simplify, we solve for t, so it would be 2t equals 1, and then in the end we'll have t equals 1/2, right? And then over here, we're going to have t plus 1 equals 0, t equals negative 1, so that would be cosine of x equals negative 1 is 1, and then the other one is cosine of x equals 1/2, and I think there's valid solutions for both of those. Cosine of x equals 1/2 would be pi over 3, 60 degrees, and it would also be 360 degrees minus 60 degrees, 300 degrees, or you could also say that as 5/3 pi, 5/3 pi. Cosine of x equals -1, that would be just one angle only, it would be the angle pi. So I think those are the three solutions. Okay. Moving on. Sine squared of x equals 2 minus cosine of x. So this is a tricky one because you've got sines and cosines. What the first step is you need to change one of these sines into a cosine. Probably the easier one to change would be this one. And you're like, how do you change a sine squared into a cosine? Well, remember, sine squared plus cosine squared equals 1. So sine squared is equal to 1 minus cosine squared, right? So let's put 1 minus cosine squared in for that. So 2 minus cosine of x. Now we have 2 on one side, we have 1 on the other. Let's subtract 1 from both, or let's add cosine squared to both sides and we'll get it over to here. And let's subtract 1 from both sides, we'll get it over here. And then we'll have 0 equals 1 minus cosine of x plus cosine squared x. And I'm just going to rearrange this so that it's the order that we usually see it in. Cosine squared is here, 1 is here, and then we're going to substitute. So instead of cosine squared, we're going to have t squared. Instead of minus cosine x, we're going to have minus t, and then plus 1. So now we'll factor this a little easier. T, and I don't think there is no, what do you call it? There's no integer solution to this one. So what we're going to do is we're going to take our equation t squared minus t plus 1, and we're going to use the calculator with poly-SMLT, which is basically like using the quadratic formula, okay, to solve it. So we press apps, and then we select 2 for poly-SMLT. Maybe you have a lot more equations in your calculator than that. And then we go to poly root finder, and then we have a second order equation. That's fine. Second order equation. Then we're going to press next, and then we're going to give it the coefficients, which are 1, -1, and 1. 1, -1, and 1. Solve. No real roots. Okay, so there are no solutions to this one, at least no real ones, and we haven't talked about imaginary numbers, so that's it. Okay, finally 2a. Cosine of 2x minus cosine of x equals 0. First, we're going to have to change cosine of 2x to a sine or cosine with just x in it, so we would use one of the double angle identities. Let's see, we would want to use one with just cosines in it, like that one. Okay, so we're going to substitute in 2 cosine squared x minus 1. So 2 cosine squared x minus 1 minus cosine of x equals 0. And then we're going to rearrange it so that the cosine squared x is first and the cosine is second. Makes it more recognizable if we put it in order of descending powers. So, and then we substitute in t for that and t squared for that. So we have 2t squared minus t minus 1, and now it's just a quadratic equation that we're factoring. 2t minus 1 to, this would just be t plus, no, t minus 1, and I think this one would be plus. Yeah, that will work out, because like this would be 1t and this would be negative 2t, so the sum would be negative t. So then we just solve these two separately. 2t plus 1 equals 0 and t minus 1 equals 0, and then we can substitute back in cosine of x, which is what we substituted in for t. Now we have 2 cosine x plus 1 equals 0, and we have cosine x minus 1 equals 0. And so we're going to have cosine of x equals 1, and then we're going to have cosine of x equals negative 1/2. And I just did a couple algebra steps there in my head. Cosine of x equals 1. That happens at pi over 2. Oh, I'm sorry. That happens at 0 and 2 pi, right? And cosine of x equals negative 1/2, that occurs at negative